A virtual method is a method whose implementation can be overridden by a derived class. So if in your base class you define a method using the keyword virtual, that means that if any class derives from that base class, they would be allowed to provide an overriding implementation for that virtual method. Any method that is not marked as a virtual method cannot be overridden. So that means that by default, any of the methods that are in your base class are essentially final. They're fixed. You can't make any overriding implementations of those within your derived class. You must mark them as virtual in order to allow them to be overridden. Now, definitionally, virtual methods, therefore, cannot be static, nor can they be private. Static, obviously, because they're not instance associated. If they're static, that doesn't make sense when we're talking about deriving one class from another. And private, that makes sense as well, because if it's private, it's not even visible to the subclass. So there's no sense in it being virtual. So you can't have either of those two keywords in the same spot as a virtual method. Now, you are required to make sure that the virtual methods you create do have a body. There has to be an actual implementation in the virtual method. If there is no body of the virtual method, then this will raise an error. To define the virtual method, it's pretty simple. We simply use the virtual keyword in the definition of that class method. So just simply throwing that virtual keyword in there is a little sign that that method can be overridden in the derived class. In the side of the derived class, if you wish to override a method in the derived class, we use a keyword override. The override keyword in the derived class definition allows you to identify the fact that this is an overriding method of a virtual method in the base class. Once again, if you have an overriding method, it must have a body. So you can't override a virtual method with no implementation. It has to have an implementation or it will fail to compile. Now, technically speaking, any override method is implicitly virtual, meaning that once again, if you were to derive from the class which overrides a virtual method, then that same method could be overridden again in the subclass below. So every override method is implicitly virtual, but you cannot use the virtual keyword when defining the override method. This happens implicitly and cannot be marked explicitly as virtual. Also, just like our virtual methods, the override methods cannot be static and they cannot be private. Well, this makes sense since every override method is also implicitly virtual, and virtual methods cannot be static or private.